Hey everyone, welcome to Science Friction, a podcast about the journey to overcome design challenges. Thank you so much for tuning in and joining us today. I'm your co-host, Avery Brookins, here with my fantastic co-host, Adam Specht. Hey, Adam.
Hey, Avery.
And today we're speaking with Justin Rooney. He is the hardware team lead at Dexai Robotics, and he's here to tell us all about their flexible robotic arm, Alfred, which is used in commercial kitchens to help prepare meals. And of course, Alfred has been designed with some self-lubricating components from igus. We're really excited to get more into the details today. So thank you so much, Justin, for joining us.
Yes, thank you so much, Adam and Avery. I'm very excited to be here.
Awesome. So I guess to start, let's just start talking about Alfred. What is it and how does it work?
Sure. Yeah. Alfred is sort of a novel robot concoction. We're taking this commercial off-the-shelf robot arm. We're putting it on a bunch of custom in-house made hardware, and we're using a bunch of new software algorithms and processes to make this overall food service robot. We're calling it your personal sous chef. But the idea here is that it's basically just a modular robot you can plug and play with existing commercial furniture, and it should be able to make you delicious meals quickly and, safely, considering pathogens and stuff like that.
Yeah. And do you need any extra stuff in your kitchen in order to plug this in? Or is it like whatever commercial kitchen a restaurant might have, they can just easily incorporate this in there? I guess how does that work, the integration?
That's a great question. Right now we're working on an off-the-shelf product from our end, and it comes with two specific refrigeration units. And all you need to do there is you need 3 wall sockets and you need an Ethernet connection, and you should be up and running. Future versions of the product that we want to be able to interface directly with counter spaces and be able to put it on the stuff that people have. And we want to be able to offer both options. If you want to get new refrigeration units and have it be a standalone product somewhere else in your cafeteria, that's fine. If you want to put it on equipment you already have, that should also be fine.
Very cool. What kind of food does this prepare and help make?
Yeah, great question. I don't know if you've been to a Sweetgreen or a Chipotle. I bet you have, right?
Mm-hmm. Yes.
They use these standard hotel pan arrangements, and there's these wells that are of a standard length and width, and you can fill them with all these different trays. And essentially, Alfred works with any of those hotel pans. And you can put them in hot line applications, you can put them in cold line applications. Right now, we're focusing on salad. So Alfred will sort of be able to pick and place all the salad ingredients into a bowl and be able to serve you a lidded and labeled bowl as a sort of a end-to-end product.
That's really cool. I mean, where did this idea generate from? Or what? I know automation is a big thing these days, but what kind of got this kicked off and started?
Yeah, it's a great question, Adam. Our co-founders, Anthony and Dave, they always tell the story of they were going around and asking, what are some of the cool things that robots could help solve in your life? And the answer they would frequently get is laundry or food. And Dave always jokes that he just went with food in there. But a little bit more seriously, even in 2018, the food service industry was in a really severe labor crisis. And I think people were typically having a lot of issues with staffing, retraining, turnover. And, a lot of these jobs, you think like a fryer and a grill, it can be very repetitive and mundane and sometimes even dangerous. So those all seem like good targets to automate. And now, 2020 through 2021, we went through a global pandemic. I'm sure you guys have heard about that.
Vaguely aware.
It's sort of exacerbated the problem. I don't know. I mean, on the daily, the New York Times podcast, they recently ran an episode about how people aren't actually returning to these low-wage jobs. So, I mean, the labor crisis for the foreseeable future isn't getting any better. It's probably only getting worse. And our solution here is trying to hit that gap in the market where there's issues.
Yeah. Besides that labor crisis, what other problems does a product like Alfred solve?
Yeah, great question. So another sort of play that we have is that we want restaurateurs to be able to focus on some of the more important aspects of running their business. And we think that can be sort of, the human touch, being able to provide a culinary experience, being able to interact with your guests that come into the restaurant. So the robot can sort of do more of the mundane tasks. And a way that we like to think about it is no one bats an eye at sort of a KitchenAid standing mixer right now, right? That's sort of become like a ubiquitous product that helps you mix food better, right? And helps you make recipes with less manual labor. We view Alfred similarly as sort of a tool that chefs can use to create amazing experiences that take off a lot of the labor-intensive burden.
What are some of the design challenges you've run into? Because I'm guessing it's a very easy sounding situation. And then when you get into the actual heart of scooping guacamole onto the rice bowl, it's not so easy.
Right, for sure. Yeah, so I think a good example here, and you guys mentioned the big igus bearing that we use in our system, that goes into our container passer arm. And that sits like a puck right below the main robot arm. And it'll swivel around the base, and it has another joint of freedom on the end. And it basically just transports the bowl anywhere within the plane where it sits, right? And we chose that particular solution for a lot of reasons. Typically you'd move a bowl in traditional automation, you move a bowl down the line using a conveyor belt. I don't know if you guys been to those sushi restaurants where there's that really, really long conveyor belt and you can like choose which type of sushi you want. That's like a good way to think about the traditional way of approaching it. This container passer, though, it's nice because it can really shadow the main robot arm, and that prevents spillage. So the closer you are to the hotel pan where you're scooping, it speeds up the product. It also prevents spillage. And basically, this was a big challenge to design because we have this big robot, right, and it can move around pretty aggressively, which generates these really big moments. So we needed to have some sort of structure there to support it. And then we also had this arm that we wanted to put under the robot and be able to go all the way around it fully revolute. So we got that slewing ring table because there was a large moment that the container passer was sort of balancing. And then we also put in a pretty large slip ring in there so you can still be fully revolute and pass signals to the arm appropriately. So that was a fun design, happened a while ago. We got it working pretty reliably. Now we're happy with it.
The container passing arm, you mentioned the moment loading. Is there some positional accuracy requirements there as well? Or is it more just containing the moment and avoiding the main arm swinging around and hitting it?
Right. It's a great question. So I'm not the expert at this, but from what I've heard internally, solving two robotic problems at the same time is very challenging, and allowing the robots basically to avoid each other in real time is really difficult. So we've actually spent a lot of time recently updating all the control solutions for the container passer so that it could follow its trajectory much more closely. Because what we were seeing is if there's lag in one of the robots, they would collide, right? And collisions are very spectacular, and you really don't want them in the kitchen space. So, like, you can imagine the bowl getting popped out of the hand, right? It spills the rest of the salad all over the workspace, and you can contaminate the rest of the workspace. So that's really important to avoid that. So yes, there's like important accuracy requirements there. And one of the mechanical pieces was that we had to really reduce backlash in all the joints to also enable controls to be able to make an appropriate controller that allowed it to be accurate enough to avoid collision.
Wow. How did you go about, and if this gets into secret sauce, obviously, but I'm assuming reducing backlash was another easier said than done challenge.
Yeah. We've been using these Dynamixel smart motors, and they're pretty good. But of course, like the mechanism designer always has to design in features or think about how to reduce backlash, because pretty much all components have backlash. So what we've really been liking to use these days are these flex couplers. And they basically eat up any sort of positional and angular misalignment, which allows your motor to live much longer and have a much longer reliability. And then also they fit really, really nicely together with these compliant materials in the center. So they pretty much have no backlash. So if you can design it with the right sort of load bearing structures and the right transmission components, we found that it's not too bad to reduce the backlash these days. There still is backlash in the motor itself though, right? You need to use anti-backlash gears throughout the motor. And I think that motor has, it has a really long gear train to reduce the speed, right? And increase the torque from the base motor spinning. So there's still a little backlash in the motor. We can't really do anything about that, but we've reduced most of the backlash on the rear end where we can control. In our early days, we were very, very cost conscious. And we ended up getting 2 Lazy Susan tables. And the Lazy Susans you can get for really, really cheap. I think they were like $5 or $10 each. And the Lazy Susan table in itself can't really resist a moment. But if you put 2 of them on top of each other, then it can. A lot of issues with binding at that point. It was hard to link the 2 tables together, but still maintain the right structure for the robot. So we needed to do a better job basically isolating the container passer's movement from the robot, because the robot will flex, it'll move the whole table. And as soon as you deflect where the robot's mounted, you're sort of interfering with where the container passer needs to move, right? So we figured out after that experiment that we needed a better way of isolating the container passer from the main robot arm. And that's what sort of led us to the slewing ring table. It's just much simpler to integrate and design around.
Cool. What are the benefits for the end user in particular by having a kind of like a igus slewing ring there versus like a Lazy Susan?
Oh yeah, I mean, these are great. You don't really need to lubricate them, right? I think your plastics are self-lubricating. They have a nice lifetime calculation, right? So I think our slewing ring table is actually rated to a higher number of cycles than our actual product is, right? And I believe you guys also have a version that's a little bit smaller. So we might actually look into getting the smaller version because it's not like we have a super high load. I mean, what we found, right, is these slewing ring tables are used quite frequently, but usually for like huge applications, like for a tractor, right? Like a tractor has this pivot axis and they use the slewing ring table so they can get all the cables through the middle. And then like a windmill will have like a huge slewing ring in it so the windmill can rotate. So finding something for like a low load application was also a challenge. And the slewing ring was, a decent price point and definitely great in terms of its specification. But what we really want is like a lower payload, lighter weight, lower cost point robot. And those don't really, well, they do exist, but not as many options exist.
Yeah, I would imagine this isn't a case where you need a full-blown 6-axis industrial grade robot to scoop mashed potatoes, but you need it to work. It needs to work reliably. It has to have the feature sets. It has to be customizable. It can't just be sort of hobbyist grade either. So right. Like you say, there's an interesting sweet spot there.
Mm-hmm. Yeah, exactly. And it's also important to have the 7th degree of freedom. A lot of the robots out there, they're only 6th degree. And recently, I'm sure you guys have heard of cobots, but the cobots tend to be 7 degree of freedom and they don't have any pinch points, right? And they have all these cool features like they'll stop when they reach a certain torque. And all of those are super important for our application too, because, eventually we would love to remove our sneeze guard and be able to have them work very safely alongside humans, which, previously you'd have like a big cage in your automated facility, right? And the only way to go and work with the robot is to enter the cage and then that shuts the robot off, right? So just a very big paradigm shift. And there's a lot of technology that goes into making it safe, right?
How safe is this? How safe is Alfred around humans?
So right now, the whole thing is enclosed, which makes the whole thing much safer. And it's important for food service regulations too, right? You don't want someone walking up to your food and being able to sneeze on it. Right now, the sneeze guard, when you open the sneeze guard, it moves the robot into its movable state. It's user stopped. And when it's in its movable state, you can actually grab it by the head and you can kind of work it in any position that you want, which is cool. So it's very, very safe right now. And at a certain point, we want to use more like computer vision to be able to remove the sneeze guard and have it be closer to workers. And we have also demonstrated that you can make that work. You can have people detection with a distance sensor, and you can figure out how close a person is to the robot, and you can change the speed that it moves, or you can stop it entirely in order for it to be safe without being enclosed.
Well, this is really interesting, and you've used you've mentioned paradigm shift before, and I would imagine on your customer end, the ability to do some of these things. Some customers are going to grasp very quickly and easily. Others maybe are going to take some convincing. No, we've always done it this way. But I mean, what an exciting product to be developing for all the reasons that you described at the beginning of the conversation. Do you find people either sort of instantly grasp the idea, or maybe there's a little resistance, or are people genuinely like, whoa, this is cool?
Yeah. From the people that we've interacted with, and it might be because, maybe there are some of the leaders and they're already more open if they're broaching us, right? But they all sort of grasp it very quickly, and they start suggesting all these other applications that we can put it in, right? Like we showed it to a chef based out of Boston. He was like, oh yeah, you guys should make pasta robot, in like 3 weeks. And we had to tell him, like, we have development times and it takes a while, but all these guys are from the hospitality industry too. So, it's all about the customer, and they grasp the technology very, very quickly. But I think a lot of the times they don't realize the amount of, sort of person weeks that can go into developing the software and hardware to make it such that it actually can be deployed and reliable and stuff like that. So much enthusiasm. I think people are really eager to get their hands on it. And I think people understand the concept pretty quickly. Yeah.
So Justin, if there is anything in store for the future, either next steps for Alfred, any of that?
Yeah, great question. So our obvious next steps are going to be trying to release our salad product and get it out to our pilots. But due to the flexible nature of it, we're hoping to expand to ghost kitchens, to commissary kitchens, front and back of house restaurants. And we're focusing on salad right now, but we could easily work with Mexican or poke or rice bowls. And we have a short video of operating a grill. And we're also looking into stuff like smoothies, fryer, ice cream. And we've already put out several ice cream demos. So look out for those different Alfred options in the future.
Well, that was Justin Rooney. He is the hardware team lead at Dexai Robotics based in Boston. Dexai Robotics is safeguarding access to prepared food, enabling more affordable and sanitary meals through cutting-edge robotics and artificial intelligence. To learn more about them and to see some cool videos of their robotic arm, Alfred, visit their website at dexai.com. That's DEXAI.com. Thanks so much for listening to this episode of Science Friction. Zach Davis is our producer, Eddie Aqueo is our sound and video engineer, and Kelsey Mariah Orsman is our graphic designer. Adam Spacht is my extraordinary co-host, and I'm your other co-host, Avery Brookins.